So we're going to do the domain and range of a trig function that's shifted. Guys, this is a trig function. It's not algebraic. It's just a shifted trig function. I suppose you could say it's algebraic because I suppose you could try to make this a polynomial, but it's a trig function. I hope at this point we all realize, without much to do, that a sine curve looks like this, right? And this is the mother function or the parent function, whatever you guys learn to call it. All right? Do that? Okay. And the parent function has a range of -1 to 1, and we know this from the squeeze theorem anyway, right? And we know that the domain is all reals. Here's what you got to see. Nothing's happening to the domain. We didn't stretch it. We didn't shift it. It is just the same. So I'll just write domain is all real. Or I suppose you could write negative infinity to positive infinity, either or. Both those are the same, right? So now, you got to say, what happened to the range? Well, the first thing that happened to the range is we multiplied it by 2, which stretches it across the x-axis. And my favorite trick in pre-calc is this. I'll just change that. Now I've made 2 sine x. And then what does the plus 1? It shifts the curve up 1. So my range in this point goes to -1 to 3, and it includes those points. All right? And again, if you think of a 2 times the domain, that would go -2 to 2, and then you shift it up 1, you get back. That's another way to look at it. But again, we should be able to identify tomorrow on the quiz the range, the domain, and the type of function. Trig. All right, sine, cosine. We should be able to identify polynomials, rationals. All right, all those types of functions.
Freshman,